deep renovation in the building sector because the climate objectives call for 55% CO2 reduction by 2030 and even 90% by 2050. And knowing that the majority of buildings will be in place in 2050, it's clear that deep renovation of existing buildings is the necessary response from the building sector. Deep renovation can be characterized by a number of key performance indicators. The most important one is energy. The objective is to reduce the energy demand for space heating and hot water by at least 60% and to increase the share of renewable energy. But equally important, it is to achieve comfortable and healthy indoor air quality and good indoor temperatures, both in cold seasons and in warmer seasons. Deep renovation is also important to reduce the CO2 emissions of building materials, in the first place by extending the lifetime of buildings, but also to pay attention to the environmental impact of building materials which are used for deep renovation. When doing a deep renovation, there are of course risks, and they can be dealt with by integrating multiple components in elements so that there is an optimized prefabricated process before complicated components are being mounted on site. It's also important to reduce the time of the physical renovation in order to generate a broad acceptance among tenants for a deep renovation approach. And finally, the costs are important. Deep renovation can be facilitated by prefabricated elements with the integration of many components, and this can help to achieve affordable building exploitation cost and affordable cost of living for tenants, and thus avoiding energy poverty. The general method and approach that has been chosen in Horizon 2020 research projects is to look at different building archetypes. And also a project called 4INEU has done the same. And this project made use of the tabular building archetypes that had been defined under a previous program. And in 4INEU, the geometries of those buildings have been taken and they have been adjusted to context-related thermal properties, both in terms of climate and typical construction methods. Europe has been divided into geoclusters, and geoclusters are countries or member states with comparable climatic conditions, and these geoclusters have been used to study the deep renovation concepts. The renovation needs in those clusters has been taken as a starting point, and these renovation needs vary from project to project, of course, but they also vary from region to region. And to highlight a few, in the northern geoclusters, reducing of CO2 emissions is an important one. In other areas, avoiding energy poverty is an important one. And in all cases, indoor comfort is a relevant one to address. The following technologies for deep renovation have been studied in 4INEU. The first and most important one is the prefabricated facade, which contains super insulation, good window frames, the addition of shading systems where necessary. But there are more technologies that are also important to achieve a good performance. And the first one is to address summer conditions and to add, for instance, a smart ceiling fan in order to have a better individual control over conditions in summer. The third one is the use of a so-called energy hub. Many buildings have a collective or communal heating system which can then be distributed better, making use of a so-called energy hub. The fourth technology is the use of balanced ventilation with heat recovery to make sure that there is enough fresh air in the apartments, but also to make sure that the heat of this ventilation air is recovered. Heat recovery can also be integrated in the prefabricated facade. In this case, we talk about decentralized solutions, because it cannot be a whole house ventilation system that you do in a facade for one apartment. And finally, the project has addressed the integration of renewables. This could be either in the facade and be integrated in this prefab facade, or in the roof. And the project has both addressed PV and solar thermal systems. All of this has been combined in deep renovation packages, where a performance evaluation has been made on the different key performance indicators that were introduced in the beginning, and they are listed here again in detail. And that resulted in 288 renovation packages times the different building archetypes that have been studied times the 6 geoclusters, and that resulted into a huge number of packages which are possible in the different areas and different geoclusters within Europe. And this is a huge information database that can be used as a starting point when planning a deep renovation in your own situation. So to summarize, a deep renovation package is characterized by the renovation needs in a geocluster, by the technology features that can be part of it, and it provides information for designers, and there are key figures in terms of performance that can be expected. And such information is a good help as an initial starting point to start a deep renovation project in your situation. Finally, I want to introduce two recent projects. These are projects that have been carried out in 2020 in the Netherlands. The first one is an apartment block of 76 social apartments in Zeist in the Netherlands. And this project, called Flat 11, has been renovated with a super new facade using triple glazing on both sides of the building, addressing thermal bridges. And this building is heated with a compact heating and ventilation system that includes a heat pump for hot water and space heating production. Every apartment has its own compact heating system thereby. And the last one is a project which has started in 2020, which is the renovation of 194 social houses in Goesepolder in Goes. And in this project, the originally brick buildings will have a new prefabricated facade designed by the consortium Built for You, and this project will have a super performance at the end because of the low energy demand, the good ventilation, and the integration of solar PVs in the roof.